A lightning bolt transfers 10 to the 9th joules of energy across a potential difference of 5 times 10 to the 7 volts during a time interval of 0.2 seconds. So in part A, determine the total amount of charge transferred between the cloud and the ground. So one of the relations we know is that the electric potential energy is equal to the charge times the voltage. I'm going to use a capital Q for the charge here because it's going to be a hell of a lot of charge. So U, the potential energy, the electric potential energy is equal to charge times potential, or voltage. And we want to find the charge, so Q is equal to U over V. The energy was 10 to the 9th joules divided by the potential, which was 5 times 10 to the 7, which is equal to a total of 20 coulombs. That's actually a really, really large amount of charge compared to what we're used to, because we normally see things on the, an electron is 1.6 times 10 to the negative 19 coulombs. So, part B. Determine the current in the lightning bolt. Well, the equation for current is just charge over time, Q over T. So it is 20 coulombs in 0.2 seconds, which works out to be 100 coulombs per second, or 100 amps. And for part C, determine the power delivered over the 0.2 seconds two different ways. Well, one way, back when we first learned about power, it was the energy over time. So this is going to be the 10 to the 9th joules over 0.2 seconds, which works out to be 5 times 10 to the 9th watts, which is the equivalent of saying 5 gigawatts. The newer definition of power is current times voltage, and the current we just figured out in part B was 100 times the voltage. The potential is 5 times 10 to the 7th, and multiplying those together, you get 5 times 10 to the 9th, or again, 5 gigawatts.